ready. So, something that I figured would be of interest to everyone who would end up watching this now or later on video is bugs inside of video games, because a lot of us are gamers. Now, there's a logical series of well, it's not even a series. It's a very few set of logical steps that you should be able to jump to. So if I say software sucks these days, programming sucks these days, programmers don't understand as much as they should, web development is absolute dog shit, etc. A lot of the pushback I get is along the lines of, no, actually, it's better than ever, because it allows us to do extremely complicated things with much bigger team sizes, and we get to move faster, we get to build more features, etc. Now, there's a jump that's made there. There's something missing, which is if programming and languages, libraries, frameworks, software, web, all of these things, if all of these things have, as a general rule, become better, then what you should see is a decrease in bugs. You should see a decrease in security vulnerabilities. I mean, there was just one today with, I think, the Department of the Treasury, the Treasury Department in the US. You should see it like, not this one. I think it's this one. No? This one. Like, this shouldn't be going crazy. This shouldn't be effectively doubling in but 2 to 4 years, right? Because everything should be better. We shouldn't be seeing more problems with video games, or regression in, say, graphics or gameplay mechanics, or things like this, especially when hardware is getting better too. Which is also another common argument I hear, which is like, hey, we can afford the cost of some things not being as performant as they should be because hardware is so much better these days, et cetera, et cetera. So are games getting better? Bugs that persist into releases of video games can have negative impacts on both developers and users. But particular aspects of testing and game development can lead to difficulties in effectively catching these missed bugs. It has become common practice for developers to apply updates to games in order to fix missed bugs. These updates are often accompanied by notes that describe the changes to the game included in the update. However, some bugs reappear even after an update attempts to fix them. In this paper, we develop a taxonomy for bug types in games that is based on prior work. We examined 12,122 bug fixes from 723 updates for 30 popular games on the Steam platform. We label the bug fixes included in these updates to identify the frequency of these different bug types, the rate at which bug types recur over multiple updates, and which bug types are treated as more severe. Additionally, we survey game developers regarding their experience with different bug types and what aspects of game development they most strongly associate with bug appearance. We find that information bugs appear the most frequently in updates, while crash bugs recur the most frequently and are often treated as more severe than other bug types. Finally, we find that challenges in testing, code quality, and bug reproduction have a close association with bug persistence. These findings should help developers identify which aspects of game development could benefit from greater attention in order to prevent bugs. Researchers can use our results in devising tools and methods to better identify and address certain bug types. So again, they go over things like, yeah, bugs are going to cause a loss in sales. It can impact the users. They will not enjoy the game. They can lose hours of progress. It can create misunderstandings between players. For example, if you're doing a multiplayer game and there is a bug, there is a frustration in the multiplayer game, whereupon the multiplayer game is no longer fun. Even though there are negative consequences to bugs, it is common for games to release with bugs that are fixed through subsequent updates. So I remember the good old days when you would buy a physical hard copy of a thing and you just got that thing and that was it. We have it so good now and we still can't get it right. In 2014, for example, over a third. I really want to drive this point right the fuck through your skull. In 2014, for example, over a third of big budget games released on Xbox One, Wii U, and PS4 received an update within 24 hours of the game's initial release. Tell me, do you think this has got better or worse since 2014? 10 years later, do you think it's become better or worse? Are games releasing fewer updates in the first 24 hours, or are they releasing more updates in the first 24 hours since 2014? It's not, I mean, it's a rhetorical question. It answers itself. I just needed an excuse to take a sip. Shout out to all my homies who bricked through Wii U on Christmas Day because of like a 10 gig firmware update. Yeah. Yeah. The differences between the development of games and development of traditional software could explain the appearance of these bugs. Prior research was done to identify the differences. For example, games typically do not have strict functional requirements. Unlike traditional software that is usually meant to accomplish a particular task, generally, the primary requirement of a game is be fun. As a result, requirements tend to be more informal and subject to change as developers continually refine the game to be more enjoyable. This is a good point. The nature of a game can change if you're going to constantly update it based on user feedback. That's fair. Additionally, game development teams are often more diverse in terms of team member background and expertise. For example, games often contain a large number of graphical assets, which requires greater participation from designers and artists. One important difference that could explain why bugs may not get detected before releasing relates to the difficulty in comprehensively testing all aspects of a video game. Hang on. Developers have difficulty writing comprehensive tests because games can have a significantly large number of possible user interactions compared to other types of software. Players can act unpredictably when playing games, and automated testing tools struggle to replicate the full range of interactions as human players might attempt when playing a game. As a result, many games release with undiscovered bugs that only reveal themselves once customers begin playing the game. Now, I would argue that in reality, this is no different than the web or software. I actually think that this is a common thing that happens in web and software too. I do not think that video games have some kind of distinct angle on this. It is often the case that you'll release a piece of software for a desktop application or a mobile app or a website, and a user will do something that you did not expect them to do, is not covered by a test use case, etc. One way developers address previously undetected bugs post-release is by applying updates to their games that fix these bugs. These updates are usually accompanied by update notes, a textual description of the changes in the accompanying update. These update notes are often published as news items on the game's website. While some updates might include content changes or additions, other updates might only attempt to fix a small number of severe bugs. Some of these smaller updates are referred to as hotfixes. These updates are typically meant to remedy more pressing issues or bugs that need immediate attention. Additionally, some bugs might reappear or recur in multiple updates. There exist cases in which developers have attempted to fix a bug in one update, only for that bug to reappear in the game anyway, necessitating another attempted fix in a later update. For example, in the game Warframe, the notes for an update posted in August of 2019 included a bug fix statement that said, "Fixed inability to complete the Mastery Rank 12 test if you fall off the starting platform." In September of 2019, the notes for a later update also included an identical line, which implies that the August update did not successfully fix the bug. Previous research has focused on creating a taxonomy for video game bugs. While this taxonomy provides a solid basis for categorizing bugs in games, a cursory examination of bug fixes described in game update notes indicated that this taxonomy did not cover all the bugs addressed in these updates. So there's some subtlety, and so essentially they wanted to expand the taxonomy, and so these are the questions that this paper asks. What are the most frequently fixed types of bugs through game updates? What are the most frequently recurring types of bugs? Are all types of bugs equally severe in negatively impacting the game experience? We have provided our data set of 12,122 labeled bug fixes and a report of the survey responses. There is some related work. So they talk about other studies that have been done that are related to what they're talking about in this study. So, for example, this Greek guy, Ampadzoglu, performed a case study on a collection of open source Java games to find possible correlations between the application rate of design patterns, the defect frequency, and the debugging efficiency, which is a study that I'm going to go through later in another somewhere in the future, because these are all good studies that also talk right back to the article we read at the beginning. So then they go over that. They tell you how they collected the data. For our data set, we used update notes from the most popular games on the Steam platform. We chose the Steam platform because Steam is the largest vendor for games on the PC system. Check that sentence right after 8. Or was that here? Borelli et al. Identified 7 types of bad smells in game projects that were created with the Unity game engine and presented Unity Linter, a static analysis tool designed to help Unity developers to detect these smells. They found that certain patterns, such as the adapter pattern and observer pattern, exhibited such correlations with defects and debugging, but could not identify causal relationships. Was there a reason you wanted me to read that, Laugh? Observer pattern. Wow. Yeah. Okay. Because you were wondering what it was. Okay. To identify a selection of popular games, we found Steam's list of games that had the highest number of players on June 23rd, 2020. We chose the top 30 games from that list, excluding items that were not really games. The list of games used for this paper can be found in Table 1 and the genres. For example, the most recent update we collected for the game Counter-Strike Global Offensive was released on 2020, which meant the earliest update we collected for this game was released on July 16, 2019. And so there's a dating on updates, right? So they continue to talk about that. Then the types of bugs. We identified that there were bug fixes that did not fit in any one of the existing types. Hence, 2 of the authors jointly applied open coding. First, we generated short descriptions of the initial 11 bug types based on the descriptions from Lewis et al. So Lewis et al. Is the base paper where they get all their bug types taxonomy. As we labeled bug fixes from our data, if we found a bug fix that did not fall under a currently available label, we created a new label. So they essentially just did their due diligence on making sure they had as many labels as they could. For example, one bug fix for the game Black Desert Online said, "Fix the issue where running left or right was impossible when transformed into an immortal persimmon knight." While part of this bug related to incorrect position of a game object, the inability to perform an action seemed to be the core problem. Therefore, the action label was applied instead of the position of object label. They're trying to be careful about how they categorize or taxonomize the bugs. Bug recurrence. So they had to manually search through the data to find all recurring bugs. Well, that's what they would have to do. At the same time, we discovered a purely automated approach could also lead to problems. A cursory analysis of repeating bug fixes in the data revealed that some repeating lines were generally written. It was unclear whether or not the fix was applying to the same bug each time. For example, The game Ark Survival Evolved had 5 updates that included the line "fixed a server crash." In this case, it was not apparent whether this line was referring to the same bug each time or different bugs that caused crashes. Conversely, 2 updates for the game Dead by Daylight both contain the same line: "fixed an issue that caused a crash when changing the graphic quality settings during a match in the Red Forest maps." Here, the apparent cause and effect of the bug are identical. Changing certain settings in a certain context causes the game to crash. In this case, both lines are likely referring to the same bug. We were skeptical that an automated tool would be able to differentiate between these 2 types of recurring bug fixes, so we chose not to use a purely automated approach either. We ultimately decided on a hybrid approach. We would use an automated approach to limit our analysis to a smaller collection of bug fixes and then manually evaluate these lines to find the true recurring bugs. So they talk about that. So this is the table: the game title, the genre, and the number of analyzed updates. So the maximum date would be June 23rd, 2020. Counter-Strike Global Offensive, 36. You can see it all here. Path of Exile, 87. Damn. Shit. Ark Survival, 80. Grand Theft Auto, 3. Terraria, 5. Sid Meier's Civ 6, 3. Warframe, 98. Interesting that they're mostly multiplayer. True. The Elder Scrolls Online, 25. Hearts of Iron, Civ 5. Black Desert Online, War Thunder, 92. Sponsored to you by War Thunder. And so then they go types of bugs found in update notes. So game graphics, implementation response, an NPC or AI does not behave in the intended manner, game audio, interaction between object properties, mostly multiplayer and mechanically complex. That's right, yeah. Game camera, interrupted event, object persistence, so collisions, objects do not enter and exit states properly, game crashes like a triggered event, user interface, players are able to improperly and unfairly gain game benefits, so like exploits. Bug severity, and so they go over how they determined whether or not something was urgent. So things like they fixed it right away, for example, that would indicate a sense of urgency. If it was a hot fix, or if it kind of like came on its own, like they pushed out a fix and it was kind of like its own thing, it probably means that it was an urgent fix, right? And so there's a sense of urgency that you can get. They also explain that there are certain types of bugs that have an automatic level of urgency, as opposed to certain bugs that are urgent simply because they may not have like a massive breaking issue, but there's enough that it needs to be fixed right away. Otherwise, there's a problem. So then they created the survey. We created a 12-minute survey using the Qualtrics survey system to assess game developer perceptions of the types of bugs that appear in game updates notes. So this is from the perspective of the developer, right? What kind of bugs appear when you're fixing these bugs in a game update? First, the survey asked participants certain demographic questions, such as years of experience, number of people in the org. We also asked participants if they had experience fixing bugs for updates to video games. The next section asked participants about their experience with different bug types in our taxonomy. For each of the 20 bug types, we asked participants to rate on a 5-point Likert scale their level of agreement that the bug type was likely to have a severe negative impact on the game experience. Participants were then informed of the 3 most frequent bug types across all updates and were asked if these results matched with their own experience. They were also offered to explain why they believe these bug types and other bug types they commonly encounter appear so frequently in game updates. Similar questions were also asked for the frequently recurring bug types. Finally, participants were asked about the aspects of game development related to bug recurrence and the challenges in identifying and fixing bugs. To find participants, we identified GitHub repositories for games and game-related tools that had been marked as noteworthy by other GitHub users. We sent the survey to GitHub users who had contributed to these repositories and who had made their email addresses visible to other users. Additionally, we sent the survey to developers of the games examined for the study whose email addresses were publicly listed on the developers' websites. We also made the link to the survey available to a collection of game developers with the intention that they would apply, snowballing to spread the survey to other developers. The survey was sent to 630 contacts. 16 of those invitations were not delivered successfully, yada, yada, yada. Overall, we received 47 responses. That's a response rate of 7%. Other important studies in the software engineering field have reported response rates ranging between 5.7% and 7.9%, indicating that our response rate for this study is satisfactory. Now, it would be nice if we had, like, say over 100, but still, I'll take a room full of 47 developers with, a varied amount of experience, kind of giving me a little bit of feedback on, what they think of things to kind of get a sense, right? The results: frequent bug types in all updates. Figure 1 shows the frequencies at which each of the 20 bug types appeared as a fix in any game update from our data. Info being the highest, graphical being the second, action being the third, UI being the fourth, trigger being the fifth, and so on. What was info? Info is let's see. What is info? Category information. Information about the game world is not conveyed to the player correctly. That's what it is. Right here. Information about the game world is not conveyed to the player correctly. The highest. The three least frequent bug types are camera, interrupted event, and exploit. The two most frequent bug types, information and game graphics, cover largely non-interactive elements of the game. This runs somewhat contrary to findings found by Santos et al. That suggest some of the difficulties in testing games are due to challenges in testing interactive elements. If the most frequent bug types are not necessarily interactive in nature, perhaps automated testing might be more effective at catching these more common types of bugs. For each of the three most frequent bug types, survey respondents were asked if they frequently fixed bugs of that type in game updates. So you see the distinction here is they tracked bugs that were reported in the release notes. Then they asked the developers at hand, does this match with what you experience when you go to fix bugs in games? 50% of respondents said they frequently fixed information bugs. 40% said game graphics. 67% said action bugs. When asked why certain bugs might appear frequently, respondents gave a variety of responses. For information bugs, some respondents referenced priority concerns, such as the one in the following survey response. Developing mechanics is the main focus, and usually information-related components are pushed down to the last of the pipeline as a deadline approaches. They are not done right. Other respondents noted that correct information may be difficult to identify if that information is the result of various calculations involving complex states and interactions. This information could also be buried in data files that testers may not be able to locate. Incorrect information might be missed because the correct information may not be accessible. You could imagine a scenario where you have static information on screen, like some calculation of a location in the game, where the developer is looking at it, it is wrong, but the developer will not do the calculation in their head. They are dependent on a pre-existing algorithm or some kind of function that gives them that location by operating those like mathematical principles, and they just kind of assume, well, it seems right, let's go with it, right? Because it might be too complicated to just quickly do in your head and do a quick gut check whether the static information you're seeing on your screen is correct or not, right? There are a number of reasons for this. Survey explanations for the frequency of information bugs include low priority compared to other aspects of the game and difficulties in finding the correct information. With respect to game graphics bugs, the most cited reason by respondents to their frequency and updates was due to the complexity of the subject. Computer graphics is one of the most complex disciplines to work with and need highly experienced programmers to make sure that everything just works. Respondents also cited the large number of cases that need to be tested. It's fairly simple to miss visual corner cases in testing. Additionally, some responses seem to speak to the difficulties in properly assessing the quality of game graphics. One respondent pointed out the game graphics can be subjective. What looks like a graphical bug to one tester may not look like a bug to another tester. Another respondent mentioned that the correct graphical qualities of the game might be highly specific and require fine-tuning to get them right. Graphics can be delicate. It can take a lot of tweaking to get something to look just right. One response noted that graphics are considered a lower priority to fix before production than other game elements. Observation 3. Survey explanations for the frequency of game graphics bugs includes complexity, a large size of testing state space, and evaluation of graphics quality. For action bugs, many of the respondents spoke to complexity in testing as a reason these bugs might appear frequently in updates. Each possible action gives the player a new way to interact with the game world. As the number of possible interactions increases, there is a greater chance that these interactions might conflict with each other. Testing all possible conflicts can be difficult to do within the development timeline, especially when dealing with actions that may or may not be executable depending on the game state. Games often have a large number of available actions, only some of which are available at a given time. The results of actions often depend on context and sometimes randomness, and actions may depend on or be changed by previously performed actions. While testing every possible action might be feasible, testing every possible sequence of actions in every possible sequence of contexts is usually combinatorially impossible. You would have to be Doctor Strange. Respondents were also asked if they frequently fix bugs of any other type from our taxonomy, why these bugs might be frequent. Crash bugs were identified as frequent by 2 respondents, with one respondent attributing this frequency to not properly checking for input sanity. Another respondent mentioned exploit bugs, stating players are good at finding them. Another respondent, who worked with multiplayer games, referred to bugs related to desynchronization of players. Under our taxonomy, this bug would fall under the implementation response label. Another user mentioned bounds bugs as a frequent concern, especially for 3D games, explaining that the collision and physics system in a game tend to produce edge cases somewhere that leads to bounds issues. Recurring bugs. Frequency of recurring bugs. Crash. It is overwhelmingly huge. Now again, I just want to point out again, if programming is in such a fantastic state, it's never been better, why are we seeing an increase in these issues? Then it's graphical, then it's trigger, then it's position, and so on. For each of these top 3 bug types, survey respondents were offered to explain why these bug types recur over multiple updates more frequently. When it comes to crash bugs, multiple respondents cited the difficulties in identifying the actual root of the crash. When fixing a crash bug, it is easier to find the single caller that passed bad data in the crash report than it is to ensure that all callers pass good data. Other respondents spoke to how other changes to the game can easily cause the crash to reappear even after fixing it. Due to how interconnected most things in games are, it is easy to reintroduce a crash after initially fixing it. With respect to why game graphics bugs would recur frequently, the responses were more mixed. One respondent mentioned that games graphics can be interdependent and cascade through fixes, while another expressed experience with having to deal with unforeseen edge cases. A different respondent reiterated the delicate nature of game graphics. A previous fix to a graphical component of the game might not have been sufficient, and further tweaking might be required to get the graphics just right. Another user pointed out that graphics bugs are the most apparent thing for the player to notice. Building off these responses, it is possible that since the quality of game graphics can be subjective, and because players more readily notice the quality of game graphics, these kinds of bugs recur more frequently because players are more likely to notice graphics that do not meet their personal quality standards, which could mean that they're more likely to express their satisfaction to developers. Because few respondents claim to see frequently recurring triggered events bugs, there are not many explanations as to why these bugs might recur frequently over multiple updates. Still, some responses speak to the large size of the test space. Events can often be triggered in many different ways. Making sure every way works is tricky and time-consuming. When asked if respondents had seen any other frequently recurring bug types, one respondent pointed to action bugs, stating that those bugs recur often for the same reasons as crash bugs. Other respondents spoke more broadly, identifying reasons why bugs in general might recur over updates. Sometimes bugs recur because some careless guy removes your fix when merging his or her code. Wait just a second. Do you mean that Git does not prevent you from being stupid? It has to do with whether management allows us the time for testing before they push out the newest code. We've all heard that one before. Bug severity. And again, crash takes the lead. Persistence and trigger followed not very closely. Okay. Agreement level to whether selected bug types are likely to have a severe negative impact on game experience. So this is probably after this, but we can have a look at that. So strongly agree, neutral, disagree, strongly disagree. So the crash obviously is going to have the most impact on game experience. And then it's going to be action. And then it looks like exploit wins by just a little bit. And then camera. In terms of strongly agree, right? General agreement, though, that's a little bit different. So you can see that even the subjectivity of what developers assume in terms of the issue that is presented and how it affects the game. Crash bugs appear to be the most severe bugs in both data sources. Action bugs, the second most severe, do not rank as highly when looking at the mined data. Interestingly, exploit was the bug type that received the third most strongly agree. But it had the lowest severity rate from the mined update data. So what might be a reason why developers feel that an exploit bug has a huge impact on game experience, and yet the severity rate of treating exploits is the lowest? Hey, Coding and Focus on YouTube, if you want to drop a link, you can drop a link. But I'm not going to be, I won't do it now. I'll save it for another stream, but I can do it. Bug fix association with game development processes. Survey respondents were asked, in your opinion, what aspects of game development, testing, designing, etc. are associated with bug recurrence in your current project or in other game projects in which you participated? 16 respondents mentioned testing as a component of game development that had a strong association with bug recurrence. Some of these responses mentioned how a lack of testing in general was linked to bug recurrence, while other responses spoke about the lack of certain kinds of testing, such as automated testing, integration testing, and cross-platform testing. This doesn't come as any surprise. Finally, respondents were asked what they believed were the main challenges in identifying and fixing bugs in video game development. Adequate testing. Identifying origin of bugs or reproducing bugs. Reproducing a bug often requires a large time investment to reach the state in which it is apparent. Games, specifically, are huge, loosely connected systems. Bugs often depend on more than one of these systems having a certain state. Code quality. The hardest part is finding an appropriate solution to a bug that isn't hacky and is future-proof to later additions to the code that might break the bug fix again. 2 responses mentioned development schedules, lack of QA, faulty development schedule, low focus on code quality. 2 responses mentioned unforeseen bugs that only appear in particular situations, such as bugs arising out of specific hardware setups, bugs that occur only with some OSs or hardware. The choice of programming language can lead to issues. Using languages with a weak memory model, such as C++, makes it hard to identify bugs caused by memory corruption errors, such as use after free. C++ in shambles. C++ in shambles. So then they talk about the prioritization. They essentially they just kind of like summarize how they prioritized, and then threats to validity, like, hey, we didn't get enough people responding, etc., etc.